All right, so I'm going to go over an example of how we use the chi-square test for homogeneity. So the general logic behind the chi-square test for homogeneity is to test if there is a difference in the distribution of a categorical variable. This is, again, pretty similar to the goodness of fit test, except you just have multiple categories. Otherwise, it's pretty much the same. So there's no hypothesis. You're just going to say that there is no difference. You're gonna assume that the distributions are divided by the same proportions or whatever. The alternative is that there is a difference. Of course, you remember you can always go more specific and like identify the exact proportion values, but it's not necessary. No hypothesis is always just going to be that there is no difference in the distribution. Alternative is that there is a difference. So we're going to use the same equation for the chi-square statistic, where it'll be equal to the sum of the observed values minus the expected values squared all over the expected values. And then we look for basically the probability to the right or greater than getting this chi-square statistic in a chi-square distribution with degrees of freedom equal to the number of rows minus 1 times the number of columns minus 1. So that's really like the only difference you have to keep in mind. Okay, so let's go through this example here. Have the color of candy, where it was inspired by, does background music influence when customers buy? I think so. So statistics students decided to investigate other ways to influence a person's behavior. They used 60 volunteers, and she randomly assigned 20 volunteers to get the red survey and 20 volunteers to get the blue survey. And 20 of them were the control survey. And on each survey, they had the first 3 questions that were the same on all the surveys. But the 4th and 5th questions were different on the different colored surveys. So for example, on the red survey, it was when you think of the color red, what do you think about? On the blue survey, it was, when you think of the color blue, what do you think about? And on the control survey, the questions were not about color. As a reward, the student let each volunteer choose a chocolate candy in a red wrapper or a chocolate candy in a blue wrapper. Here are the results. All right, so she recorded what color candy they picked. That's interesting. So we have the distribution of people who got red surveys, blue surveys, and the control surveys, and whether or not they picked red candy or blue candy. So let's draw a graph to compare these so we have a visual of exactly what we want to analyze. So we'll just use basically side-by-side bar graphs. That'll be make the most sense. So we'll have one for each color survey. So we'll have the red survey. Then we'll have the blue survey. And we'll have one for the control survey. And we want to basically calculate the proportion of people that picked the red candy from the red survey, blue survey, and control survey, and blue candy from each survey. So let's convert these into percentages. So 13 over 20. This will be 65%. Then this will be 35%. 5 out of 20, 25%. This will be 75%, and 8 out of 20, that'll be 40%, and then 60%. So we'll draw bar graphs corresponding to those heights. So let's go by 20s, I guess. That'll probably be the most convenient. 20, 40, 60, 81, 20%, 40%, 60, 80, 100. And on the red survey, 65% of them chose the red candy. We'll have a bar going up to about here. 35% chose the 35% of them chose the blue candy. And we'll have our key. We'll have the shaded bars be the blue candy. Let's make our key here. Red candy, blue candy. The blue survey, we have 25% and 75%. So it's like kind of the opposite. That's interesting. It's just a sketch, don't freak out. It's not perfect. And the control was 40% and 60%. So by looking at this, it's kind of clear that it seemed like the volunteers were more likely to pick the color candy that matched their survey color. But now let's go into an actual calculation so we can not just, go based on like our assumption of that. So we're going to start off by stating our hypotheses, which will be that we're going to have the claim that there is not a difference in the distribution of color choice among each group. That'll be our null hypothesis, or HO, versus our alternative hypothesis saying that there is a difference in the distribution of color choice among each group. And we're going to use an alpha equals 0.05 significance level. So our plan then will be to use the chi-square test for homogeneity if the conditions are met. So we were told in the problem that each treatment was assigned at random. 10% condition, it's not necessary because we're doing an experiment. So we're sampling without replacement because we have volunteers. And then large counts. We want to calculate that all the expected counts are at least 5. So let's actually flip back. Let me flip back to that right now. So just we can before I show you that. So expected counts, like what would the expected counts be for each of these if we assume there's no difference? Now, don't jump straight up with it being 50%, 50%, because that's the initial inclination. What we do is we calculate these proportions, 26 out of 60, and 26 out, that'll be about 43.3 repeating percent, and then 34 out of 60, 56 point repeating percent. So these are going to be the expected proportions, so that if there was no difference, we would say, oh, 56% of the volunteers should pick the blue candy despite what color survey they have, and the other 43% of them would pick the red candy despite what color survey they have. So don't just go with the initial 50-50 percentage, because that's usually what the instinct will be. So we basically multiply these by the totals in each column. And since the columns are all, divided equally, we would get the same 3 numbers across. We would get all our expected counts to be about 8.67 for the red candy. Again, that's about 43%, and about 11.33 for the blue candy, which is about the 57 percentage. So all these expected counts are at least 5. So then we can go ahead and calculate our chi-square statistic. Now, I'm going to show you a very useful way to calculate this quickly in your calculator. So pay attention, so you don't have to worry about doing this tedious calculation by hand. So what you can do is you can go to, in your calculator, go to matrix on the left here. And if yours are not maybe in 2x3s, select the first, go to edit and select matrix A and change it so it's a 2x3 matrix. So it matches the dimensions of what we have here. And then you're going to enter in that 2x3 matrix the observed counts, the 13, 5, 8, 7, 15, and 12, like here. So make sure your matrix looks like that. Then from here, you're going to go to stat, go to test, and you can actually run the chi-squared test straight from here. Scroll down to chi-squared test. We're going to have our observed from what we entered in matrix A expected, or we want to see our data spit out. So if I just a matrix B, that's usually convenient. And we have two options, calculate and draw. So I'm going to show you both of them. Calculate will simply give us our value of chi-squared and our p-value of 0.0359 and our degrees of freedom. So bang, there you go. You get it without having to do all that tedious calculation. And this is okay on the AP exam as long as you write that you did technology and it gives this. Because again, it's not about doing tedious calculations on your exam. It's about demonstrating that you understand the concept. Now if you go back to your matrix and go to matrix B, you're actually going to see the expected values out there, the ones which we calculated already. Pretty cool. And now let's look at the other option. You go down to chi-squared again, and this time go to draw. It's actually going to generate a little, I mean, this is not, in 2020s, these calculators were made a long time ago, but it's going to generate some, some sketch of what you would be looking at. And it's going to, basically be that area right there to the right of 6.65. So again, just write that all out by hand to justify, what you did. We get a p-value of 0.036. So then, since our p-value is less than our alpha of 5%, that means that we're going to reject our null hypothesis. We're going to reject Ho and say that we have convincing evidence that there is a difference in the distribution of color choice for each group. So we basically are saying that, yeah, it seems like the color survey probably will influence your color choice. That does make sense. All right, so there you go. I hope that helps. Good luck.